In the examples we have studied so far in this unit, in the last we have only performed one transformation on a figure most of the time. We can also perform more than one transformation on a figure. In the following problems, you will perform a sequence of transformations on a figure, which of course is part of our objective today. And it is also one of the standards which is on the test, which we did some before in the last unit, but that has been changed or transformed into this unit. Oh, very nice. Well, right account, number one, we have triangle ABC, and we are going to reflect it, looking at A, over the y-axis, which is these, right account. And label the image triangle A prime, B prime, C prime. All right, so let's start with C, because it's closest, I guess. This is 2 to the left, and reflection means we'll go 2 to the right, and this gives us C prime. A is 6 to the left, so A prime must be 6 to the right. There we go. And that would give us A prime. B is 3 to the left, so B prime will be 3 to the right. Bam. B prime. Now all we must do is connect those points. And now we have a reflection of triangle ABC into triangle A prime, C prime, AB. Yeah, I got it. All right, now part B says it wants us to reflect these over the x-axis right here. But we're reflecting A prime, B prime, C prime triangle. So now instead of looking for left to right, we're looking for up and downness on the shape. All right, so C prime is 1 up, so C double prime will be 1 down, right here. And B prime is 4 up, so B double prime is 4 down, right here. And then we'll do the same thing with A, 3 up, so 3 down is the reflection. That gives us A double prime. And then, of course, we'll connect the points. There it is. So we reflected this over the y-axis and then over the x-axis, and this is what we got with our first image and then our second image with the double primeness. So now what one transformation is the same as this double reflection? A couple of them, yeah, rotation would work. How much of a rotation? 180 degrees. In which direction? Doesn't matter. That's right. 180 degrees in any direction with the center of rotation at the origin. Bam. Now, what else could have worked is we could have reflected this over the line y equals x as well, which we've seen before. Triangle DEF has been plotted below. Reflect triangle DEF over the line x equals 1. Let's see what that line looks like. X equals 1 is right here. Well, that was close. There we go. That line, the red one, is x equals 1, and reflecting triangle DEF over that. So, let's go ahead and figure out how far away these are, right? So E is 4 to the left. So E prime will be 4 to the right here. And then D, this is 7 to the left. So 7 to the right here. And then F is 3 to the left, so 3 to the right will be F prime. And then, of course, we need to connect these points. And there we go. So now it wants us to reflect triangle D prime, E prime, F prime over the y-axis and label the image triangle DEF double prime. Okay. And that is over the y-axis, which we should mark. And I marked it in purple right there. So over those green lines, we're going to need more of these. So F, for example, is 4 to the right. So F double prime will be 4 to the left, right here. F double prime. D is 8 to the right. So D double prime will be 8 to the left. And then finally E, which is 5 to the right, so E double prime will be 5 to the left. And let's just connect those. And there we go. Information would take us from our original pre-image, triangle DEF, into our double image, triangle DEF double prime. A translation would work, and it would be a translation 2 to the left, so the coordinate rule then really isn't too bad. So we got our coordinate rule set up. I'm going to take x and y. In this case, we're going to take the x, and we're going to move it to the left 2, and the y value didn't change at all, so there's a nice coordinate rule there. Reflect quad over the x-axis and label the image quad prime. So let's identify where the x-axis is first. That's this one right here in purple. So we're going to make a reflection first over that line. So U is down 1, so U prime will be up 1. A is down 3, so we're going to go up 3 to A prime. Q is down 1, so Q up prime will be up 1. And D is down 3, so D prime will be up 3. And we'll connect those. And there it is. A nice reflected quad over the x-axis. Now it wants us to translate quad prime according to the rule xy, where we got the x plus 9 y. And we'll label this quad double prime. So since it's x plus 9, all this means is that we're going to move each of the points to the right 9 spaces. So we'll show this. 9 spaces, there's 2, 4, 6, 8, 9er. So this would be A prime, right here. And U prime as well, there's 3, 6, 9er. There we go, 9er. So that's U double prime. That should be A double prime as well. Now the other ones I'm just going to go in relation to these other points. For example, Q is 3 to the left of U prime, so it'll be 3 to the left of U double prime as well. And that's Q double prime. D is 5 to the left of A, so D double prime should be 5 to the left of A double prime. So that gives me D double prime. It's just a different way to look at it. And now we'll connect these points. And there we have it. A double prime image of the pre-image quad. Triangle LMN is graphed on this grid. We're going to rotate triangle LMN 90 degrees clockwise about the origin. And we'll label the new triangle L prime, N prime, N prime. Okay. So we're going to have 90 degrees, and this is clockwise, so it's going to go in this direction right here. And N, well, we could start with L, it doesn't matter. To the center of rotation right here. That sloppage is down 1, to the right, 6. So the new sloppage should be up 1, I'm sorry, not up 1. It should be up 6, and then to the right 1. That's the opposite reciprocal, which will give us 90 degrees. So I'm going to go up 6 to the right 1. Now it is possible it could have been negative 6, down 6 to the left 1. But that would be 90 degrees counterclockwise in this case. So clockwise puts L prime right here. And we'll do this with all the points. For example, N. This one has a slop of down 1 to the right 2. So N prime will have a sloppage of up 2 to the right 1. So up 2 to the right 1 from the center of rotation gives us this point, and that is N prime. Finally, we got M. This has a sloppage of down 3 to the right 2. So the sloppage for M prime will be up 2 to the right 3. Up 2 to the right 3 gives us this point right here, M prime, making sure the line, kind of. And now we just need to connect these points. And we have rotated this 90 degree. We can see the 90 degrees on each of these. The green is right here, the red is right here, and the purple is right here. Alright. B. Dilate triangle L prime M prime N prime by a scale factor of 3 with the center of dilation at 1, 2. So now we got a scale factor of 3 and the center of dilation at the point N, that's 1, 2, right here. So, since we're doing this by 3 right here, we need to expand this. And one thing we should know about dilations is that all of the image points should go through the same lines, like this, starting from the center of dilation. So, for example, from the center of dilation at N to L, that's 4. So we'd go up another 4, that would make it twice as big, and then another 4 right here. That would become L double prime, because L is 4 away from the center of dilation. Next up is M prime, which is 2 away. So we'll go 2, 4, 6 away from the center of dilation, and this would be M double prime. The nifty thing right here is that N prime is right at the center of dilation. So N double prime will be in the same space. Because it's 3 times as away from 0, which is still at 0. Okay, well let's just connect these. Something like that. Next up is a statement that shows the relationship between triangle LMN and triangle L prime M prime N prime. So we're just looking for a congruency or similarity statement, really. So right here. Okay. Well, triangle LMN to triangle L prime N prime N prime, that was a rotation which maintains, and we should know this already, congruency. So these two are congruent. However, the next set, triangle L prime M prime N prime and triangle LMN double prime, this one was a dilation which maintains similarity, not congruence. So let's list 5 other relationships between corresponding angles, sides, or whatever that you know to be true based on the relationships in parts C and D. Okay, well, similarity and congruent. Angles should be the same. So this one's kind of, well, 2, I guess. Maybe even 3. Right here. And we can do that with all the angles, as it turns out. Because we know with similarity and congruence, the angles remain the same. There's another set, which we love, right? It's very nice. And then we got another one. Alright, that'll do it. We could make some statements on the corresponding side links, but only between congruency for triangles LMN and triangle L prime, M prime, N prime. Bam. Let's dilate LMNO by a scale factor of 2 with the center of dilation at the origin. Label the new quadrilateral L prime, M prime, N prime, O prime. Okay, so we do have the center of dilation at the origin right here. And this one will be a scale factor of 2. So once again, we could identify these. So the reason I'm drawing those lines is I know all the corresponding points should be on them, because the center of dilation is connected to the pre-image point and its corresponding point in the image. And in this case, we're just going to double that with a scale factor of 2. So for example, O right here went up 1 to the right 1, so we'll do the same thing, which puts us right here. And that would be O prime. Same with N, that's up 1 to the right 5, so we'll go up another 1 and to the right another 5.
Wait, for O prime, did you go up? You went.
There we go. I drew that line for N a little bit better. And now this is N prime. Same with L, that's up 3 to the right 1, so we'll go up another 3 to the right 1. That's this point right here, L prime. And M prime, the same idea, up 3 to the right 4, up 3 to the right 4, this point. M prime. Let's connect these. And now we've enlarged that twice as big. And it looks very nice. Now let's reflect that new image, element O prime, across the y-axis, which is that purple line right here. So to reflect it, O is 4 to the right, so O double prime will be right here, 4 to the left. L prime, that's a nice one, 2 to the right, so 2 to the left would be L double prime. M prime is, that's 8 to the right, so 8 to the left would be right here. M double prime. And then N is 10 away, so 10 to the left as well. N double prime. And there we go. Now it has been dilated and then reflected. Now let's write a statement that shows the relationship between L prime, N prime, N prime, O prime, and the double prime. Okay. All right. What should we put between these two to make a statement? These two are similar. However, these two are more than just similar. They're also congruent. So we'll just put the congruent sign between them. Number 4 in the picture below, triangle 1 has been transformed to obtain triangle 2. Which one transformation would carry triangle 1 onto triangle 2? Yeah, that would be good. What 2 transformations would give us triangle 1 onto triangle 2? Yeah, you could reflect over the x-axis, then the y-axis, and that would give you the same image. So about number 5, again it's triangle 1 to triangle 2. What 1 transformation would give us these? 1 translation would do it. What about 2 transformations? That would work. Bam. There are easier ones, by the way. For example, you could say that you could dilate it with the scale factor of 1 and then translate it up 4, but that seems too easy. Describe a transformation or sequence of transformations that would carry triangle 1 onto triangle 2. There's a couple. If you found the right center of rotation, you could, well, no, you still can rotate it. It looks like there's going to have to be some kind of reflection involved because the orientation has changed. So a reflection and then maybe a translation is what I'm thinking. I'm looking at a reflection over the y-axis and then a translation up 3. Describe a transformation or sequence of transformations that would carry triangle 1 onto triangle 2. For this one, there's a couple actually. You could have 1 transformation. That would be a rotation. A rotation about this point. That's a 180-degree rotation. Or, in some cases, a reflection. But most of us would be looking to make a reflection over the y-axis and then a reflection over the line y equals 2. Now number 9, describe a transformation or sequence of transformations that would carry triangle 1 onto triangle 2. There are several that would work in this case. Probably some kind of rotation or a reflection and then a translation. It's really up to you guys. Determine whether the following transformations or sequence of transformations will result in similar figures, congruent figures, or neither. And then we'll justify it. Okay. A, this one would be congruent because it is simply a translation. And translations, rotations, and reflections, any combination of those or individuals will result in congruency. What about B? We've got this transformation xy to negative xy. That's a reflection followed by xy transforms into 2x, 2y. That is a dilation, and dilations maintain similarity. And then we have C, xy transforms into 2x, 3y, followed by a reflection up across the x-axis. Reflections are nice because they maintain congruency. However, in this case, since we multiplied the x by something different than the y's right here, that is going to make them neither. The scale factor is different for the x's than it is for the y's. All right, E, xy transforms into 1/4 x, 1/4 y, followed by xy, then yx. Okay. Well, the 1/4 x, 1/4 y, that is going to be a dilation, and then xy transforms to yx. I believe that's it's not a 180-degree rotation. Then F, xy transforms to x, y plus 4, followed by a 180-degree rotation. This is once again a translation followed by a rotation. So they would be congruent.